Hello and welcome everybody. In this video I'm going to show you how to train a machine learning model, and in this video I'm going to use Xgboost for a multi-class classification problem. So I'm going to show you how to explore the data quickly, build a robust cross-validation function. Then I'm going to show you a few tricks on how to fine-tune your Xgboost algorithm. I'm going to explain to you what each parameter do and how to use it properly. Then we're going to save and score against the test data, and in this case I have picked up for you a data set from Kaggle. So I just picked one that is a playground using tabular data, and what you should know is that Xgboost is very powerful. It's the best algorithm so far, along with LightGBM, suitable for tabular data, and for the images and natural language processing. We know that neural networks are far better than any other algorithm out there. So personally, I use Xgboost whenever I have a classification problem or a regression problem using tabular data. I'm going to show you now how to use it properly. So if you go to this page, I've put the link down on the video, and if you scroll down you can see that they have a train, test, and a sample submission files. You just hit download all, and in this case I'm using JupyterLab, but you can use any editor you would prefer. So I like you to use JupyterLab because I can see straight away on the screen the output, and it's very good tool if you want to do the experimentations. I like it because you can see the outputs duplicate cells, and I'll show you how powerful it is to use JupyterLab for experimentation, but I would not recommend it to build the final code that you will use to deploy your model in your application. In this case I'd use an IDE more like PyCharm or VS Code. So let's get started. I'll import pandas because we're reading a CSV file, and so let's load the training data. Here we're gonna show a few lines just to see what the data looks like, and what you can see here is that we have an ID, several features that are anonymous. I guess that it's on purpose that they did this, and the value seems to be 0 or something. So yeah, I guess that those are made categorical variables. So, and then you have the target, which is a multi-class target. So what first I do is that I look into the data frame to see if there is any missing values, and then try to fill those. But in this case I don't see any missing values. There is no everything is an integer. So here, if sometimes if you have dates, you might want to change those dates into some kind of variable where you put today minus date. So sometimes you have some missing values that can be inferred from another, something like that, or you want to do some feature engineering between some of them. Here they are all anonymous, so we can't do much about this, and the course is not about this. It doesn't cover the feature engineering. It more covers the training of the model and the fine-tuning of the parameters. So let's see what's inside those variables. So if I loop for column in train data frame dot columns, just to see what's inside those columns, I'll print using these expressions. So I'll print the name of the column, right, on a 25 character. Then let's print on a 7 digits. Let's print the number of unique values per column. So here I'll use the function nUnique that gives you the number of unique values within an attribute in the data frame. Then we want to have a look at what's inside each column. So what I'm going to do here is just take the first tray, for example, just to have an idea on what's inside those columns. So here what I'm doing is I'm taking the column that I'm looping on, taking the unique values. This will give you all the unique values, and then you take the first tray. This is just to see what's inside, right? Yeah, well, no, it's not C, it's column. So this is a really neat way to look at your data. I like to put it this way, so because you can see here that this ID is just an auto increment ID, doesn't have any meaning. This probably should be removed later. And what also is interesting here is that we can see that all these variables are categorical. Like the maximum of all of them is something like, yeah, I think it's this one, 58, which means that we're not dealing with continuous data. Most of these are just categorical. And it's fine, really, because Xgboost handles very, very well the categorical variables. So I wouldn't worry much about this. In other cases, in other real world scenarios, you might find that half of them is categorical and the other half is continuous. And generally, the continuous variables has high cardinality. Like you could see, like 10,000 values, and some of them can be float. And this helps you, at least see what's in there. And then, if you want to build a pipeline, then you have to, split your data from categorical variables and numerical variables. So the first thing you want to do is build a function that will help you train your model. I have prepared one for you, and I've put it, the link giving you access to this code is down below the video, and I'll explain to you what every line here does. Okay, so this is a generic function that I use every time I'm dealing with a classification problem or a regression problem. I just have to adapt a few things. So the first variable here is the pipeline. So I usually use Scikit-learn pipelines because it's really good to have that, because you have to encode sometimes the variables, you have to do some min-max scalar, etc., etc. So I like to put them all into the pipeline so that it helps me have an accurate data transformation and scoring model within the same thing, because it avoids to have any data leakage, and Scikit-learn handles very well the fit transform methods within the pipelines. And if you want to have more information about these, you just go to Google and type Scikit-learn pipelines, and then you go to the pipeline and you can see how they are using it. So for this example, they are doing a standard scalar and then a vector machine model. So the same way you can build it and do a standard scalar and then an Xgboost model. So let's go back to our function. Here we have the training data, the target data, which is the target here, and then the columns used for the training, how many cross-validation split you want to do. This is optional. You can give a group to split. If you have a column that has groups and you want to split and stratify by these groups, and then NC is to ensure that you have the same result if you run this twice, and verbose and fit parameters, this is the algorithm hyperparameters. So let's go into this method. The first thing you want to change, if you want, I use shuffle split to create the cross validation, but you can use any other function from Scikit-learn that does the cross validation split. Here I'm dropping the group column, which is the ID, because we don't need it for the training. So we go into this loop. I'll explain why I've put those two variables at the end. So inside this loop, what we're doing is that we are splitting and creating the train and validation splits, and I am creating the data frames and the targets using those indexes. I'm just doing some prints here. And then, as you can see here, I'm using the pipeline to fit and transform on the training data. Then I'm using it as a transform on the validation. Then I am using the Xgboost Classifier using parameters. And this is optional, but just to say that I'm not encoding the labels using Xgboost, but using an external library. So here in the fit, what you can see is that I have put the training and the training data here. Then the evaluation set, I've put both so that I can observe, and I'll show you later, the performance of those two in parallel. Using the evaluation metric, you can put some sample weights, but I didn't in this case. So the evaluation metric here is multi-class log loss, and you can put any evaluation metric you need for your project. For example, in binary classification, you wanna put the IUC, rock IUC, so you can put it here. Any evaluation metric that is valid for Scikit-learn API. Variables, so here we're gonna show every 100 step those metrics, and we're using early stopping here, so it stops every when there is no improvement after 50 rounds here. So I've put those two variables because this is what we're gonna get as results of this function. So the first one, we wanna estimate how many iterations the algorithm needs to converge. So we're appending every result for every single cross-validation step here. So I'm appending this n estimators, and then we want to have the score for that cross-validation, so we can see what's the mean score and standard deviation of that score, to see if our model is consistent no matter what split it is on. So let's execute this. Then we're going to use it now. The first thing we're going to do is to create our parameters. So for now, I'm just going to put n estimators as 150 at 1500. Why 1500? It's because I usually use the early stopping to get to 1000. Okay, why 1000? It's by experience a model that I try to tweak the other parameters, because it's very linked to the learning rate. So you have another one that is the learning rate, and this one I will put it at first to 0.1. So I'll try to play with this one until I get into 1000 rounds, Xgboost estimators, and this on all the validation steps. Okay, cross validation steps. So let's leave it like this. Okay, let's build a pipeline that is from Scikit-learn. So from let's look. So it's Scikit-learn.pipeline import pipelines. Okay, so if you want to build your pipeline, you can do pipeline, then steps, then you put something in there, right? So let me give you an example of what you can do in those steps. So here I prepared some for you, right? So let's look at them in details. So you can, as I told you earlier, you can split your data into categorical variables and numerical variables. So you can put a specific transformation for each set of your columns, right? So for example, if I want to put the categorical variables like one, if you want to have multiple transformations, let's put this as a feature 1, feature 2, and feature 3. So what I want to do is apply a specific transformation to those 3, and the others do nothing. Okay, or I want to do a numerical variables 1, and for the features, feature 4, feature 5, and feature 6. I want to do another transformation that I will call here a numerical transformer. So I want to do here a scalar, and from Scikit-learn I'll just do a standard scalar, so I have to import this. So from Scikit-learn dot processing, I think, import scalar, standard scalar. So let's put this here. Okay, then for so what I'm gonna do here is create a preprocessor. So in this processor we have transformers, and in the transformers what you have to do is give the name of that transformer. So this is for categorical variables 1, and you want to do this, right? And for only so you want to do it for only the categorical variables 1, and you create another one and you call it numerical vars 1, and then you apply it to the numerical you apply the numerical transformer, and for only the variables that are in this list. Okay, so this might look a little bit too much, but it's really handy when you want to put everything within a pipeline and then do the cross validation or the training, then the scoring, everything is in one place, which makes it very powerful because you don't have to write too much line of code of transformation afterwards. So the pipeline of transformation that we will have, pipeline is a pipeline, and the steps are pre-processing, and this transformer here. Okay, and then you can add another one which is like the classifier, and you put your classifier here. Okay, so we're not going to do this part because I'll show you later how I'm going to include it later, but this is an experiment. I want to experiment now. My classifier, I want to, create it here. You can see that I've created it here. I just need the transformation pipeline, and just bear with me. I'll explain why I'm removing it from here later on, because we're going to include it once we get the final parameters from here. So this step is really just to help you fine-tune your hyperparameters, and then you can just add it and do the fit and train your model with the final parameters. So we have created here, we have an error. That means that this is have not been imported. So let's import the from Scikit-learn processing import in ordinal encoder, and we can just put the name here. We need to import numpy as right. So handle unknown is probably, we don't need those anyway. So here we need to import also from, so let's look on Scikit-learn transformers. So it's from compose. So let's import them from compose. Compose import. Right. So now it's working. And then let's call our function here. So the pipeline is our pipeline that we created here. The training data, the xtrain, is our data frame, but we need to remove the target from it. And let's put as a copy, just to keep it clean. Then the label train is target data frame target values, and so number of splits we want to do, I usually put as high as possible. 10 is a very good number, but let's just put 4 or 5 here just as a demonstration so they can run quickly. So the groups split is the ID, so this is the ID, and let's leave the others, yeah, and the fit parameters is our variable that we created here. So let's run this. Yeah, one thing that we did not do is encode. So what you can see here is that the values are in string, so this is probably not going to work. So you have to create an encoder, you have to encode those into 0, 1, 2, 3, 4. So what we are going to do now is create an encoder. So let's call it a target encoder, and it's going to be an ordinal encoder, right? And we will fit on those reshape -1 1, and so that will create our encoder, and we will use it to transform these -1 and 1. So if you want to see what it looks like when you transform them, I'll copy this and show you. Yeah, we just need the parentheses here, and it's a reshape, not shape. So you can see that it created an array with values like 1, 0, and 2, which are mapped behind the scene to class 1, 2, 3, 4. Okay, so let's copy this back into our function and run this piece of code. Okay. Yeah, he is asking for the columns to use for the training. So you might want to just put them somewhere. So in this case, we're going to use all the columns apart from the target. So what we can do is just take these and put columns, and we run it. You can see there is an error. We need to import the shuffle split. So let's look where the shuffle split is. It's in model selection. So from Xlearn.model selection import shuffle split. Okay. Let's see what the error is. All right. Okay, I think there is an error somewhere with this. Let's look at that. This looks fine. Okay, let's try this and see. Train data frame dot log everything and those columns. Okay. Yep, I know why. So we need to remove the ID as well because it was removed before that. Yep. Okay. Another error. Here the error is that there is a category that is unknown, and we can solve this. So let me explain to you what happens here. So what happens here is that we have in the pipeline we're doing an ordinal encoder, okay, using those three categorical variables, and when he does the split between the train and validation, there is some variables, some categories that he doesn't find when he tried to do the encoding. So for example, in the feature one, there is if in the train we had all the values but the 131, and in the validation we had the number 31. When he tries to encode it, it doesn't work because he haven't seen it before. One thing you can do here to solve this problem is to import a category encoder. So from category, I don't think I have installed those, but let me show you category encoders. So this one, it's a library that is compatible with Scikit-learn, and what's interesting about it is that it has the handle unknown and handle missing. From category encoders import dot ordinal import ordinal encoder. All right, so we have imported it, and now let's try to make this work using that API. So we have the handle unknown, and we will handle unknown as missing. We just put missing here, right? Okay, let's try. You can see that it's working. Let's run this now. Key error. This is very annoying. Let's see where the error comes from. Okay, so now I've managed to make it work. I have put both of them here. You can see that it's probably a problem of shapes really. So I have put back the ordinal encoder to be used as a target encoder for the the target variable, and then I used the other one, I kept it into the categorical transformer. Okay, so what you can see here is that we are doing the cross validation as I have explained earlier. You can see that we're printing every 100 step the log loss, and the first thing you want to see here is that we're not exceeding 200 rounds. So it means that our number of our learning rate is too big. So we want to lower this one, lower the learning rate so that this value becomes bigger. And I'll pause the video and until this one is done. Okay, so what we can see here is that we have 5 validation steps. We have a score cross validation that is 19099 plus or minus the standard deviation. We have the early stopping rounds that you can see that are consistent. They are around 100, and what we want is to make that a little bit better. So what we're going to do is divide this by, I usually do by 3, but since this is too low, I'm going to go a little bit more aggressive on this one and divide by 10. So we're only going to fine tune this the number of estimators until I get it into 1,000. Then I'm gonna fine tune the others to make the score better. Okay, so let's try this one. And you'll see the number of iterations will be far much, it will go further than just 100, and we'll probably have a better score. Actually, I'm gonna add a parameter that allows multi-processing. So you can put like, I want to grow 10 trees at a time, and this will speed up your training process. You could put it, I think it's -1. It will pick up any available CPU. I like to control those, to leave some for my system to run properly. So I have 12 CPUs, and I'm gonna just give him 10 to grow and do the training. So if you have bigger machines, you can put a lot more here, and it will speed this up. So just think of it as a speeding method. You can also use I think tree method. So this one is really cool. I like this one. It's a parameter that use histogram estimations in growing the trees, and it's much faster than the default one, and it gives really close results as the exact one, and is much faster. So I would recommend to use this one. I use it all the time, and so I'll stop. You can see now that it grows something like 1,200 trees. So let's stop it here and make it run faster. So let's use those parameters, and I've lowered the number of splits to 4 just to make all this a little bit quicker so that we can see all the rounds. So now you can see that it's running really quickly. You can see the iterations are running one after the other, and it's like one every second or one every second and a half, and the results are very similar. So this reminds me that I should copy paste this to keep log of the previous scores. This is to keep track of what you had before, so that you can see if the modifications that you've done is making your model better or worse. Okay, so this is the second step of the cross-validation. I'll try to make this a little bit less verbosy, so I'll put 200 there, 250, so that we can have less lines per validation step. So now, as you can see, we managed to get our cross-validation function running efficiently. We have a number of n estimators around 1000 for each one of the cross-validation step, which is good. And then we have our score here that we're going to try to improve now using the hyperparameters. So let's go to the Xgboost parameter page. So you just go and type Xgboost parameters on Google, then you pick the first link and you go down here and you can see in the parameters of tree booster a set of parameters that are used, within the JSON parameters for the model. So I'm not going to explain all of them, but I will go through the most popular ones and the one that I use most often. So the first one here is the maximum depth, that is by default 6, so it's the depth of the tree. So if you increase this one, the tree will be more complex and more prone to overfitting, so you might want to keep it in a reasonable value. And I have copied this one here, so you can see max depth is equal to 5. I've decreased it to see if that improves our model, because I can see that there is a gap here between the training. It's not that big, but there is a gap there, and I want to see if a less complex model can make that gap closer. So another thing that I usually use, and it's really good to use this one, is the subsample. And the subsample is, I usually put it between 70% or 80%. You can choose, or you can test both. I'll not use it. I will not use it now, just to show you the effect that it can have. This one means that whenever there is a new tree being grown by Xgboost in a training step, it will use only 80% of the data, and this is good because it's going to learn rules from different parts of your data, giving it an ability to generalize on new data. And by experience, this helps you build a more robust model and more generalized model. And the same way we're doing this with the sample or the records, you can use this one to do a column sampling. So I take this one here and I also use it to do the column sampling, and I give it something between 80% or 90%. Okay, we will not use it until we see what's the effect of each one of those parameters. So lambda, alpha, these are regulation parameters. I don't use them. I've never used them before because the other regulation parameters makes it so much better than those. So one of them is gamma. So gamma is a very good regulation parameter that you can use, and I will not cover it in this course, but generally it's a value between 0, which is no regulation, and 20, which is a pretty big regulation. So you might want to fine-tune this one when you have a high gap between the training and validation. So let's I'll leave it this way, okay? And let's try to run those three and see what it gives us, and then I'll come back and improve if we can. So let's run the code here and see. Yeah, one thing that I did not do here, but I would recommend to do it I will do it for the next rounds, is to copy paste. This will help you keep track of the previous runs, so that you can just go back and look and see if it has similar scoring. So what I'm gonna do here is just wait until this finishes, and then I will run another one and see if I improve my score. I remember that in the previous one we had something like 1099 in the cross-validation average. We'll see if this gets it better. One thing that we noticed here is that when we got the max depth in, it decreased. The number of trees, so here we're doing an early stopping too early, which means that the algorithm didn't finish learning, and you need to pay attention to this because you want to really use the early stopping to stop when the model don't learn anymore. So let's leave it to finish, and then I will come back and increase now the learning rate. So remember, you need to keep it around 1000 and then play with the others, and if it affects that, then come back to the learning rate until you keep it to 1000 and then improve. So it's like a circle where you have to make it to 1000, then fine tune another parameter, then come back and tweak it until you get a very good model. So our score here is 198. We improved it a little bit, so we know that the model didn't stop training. So we will increase this. Let's make it 0.2. Okay. So let's make it 0.2 and let's run it again. So as I told you before, we'll keep this one here, and then just to make it shorter, maybe increase this into 500 and run it again. You see now that we stopped at 855, which is close to 1000, and that's okay. We really want to keep it close to 1000. We can come back and make it 0.18 to reach 1000, but doesn't really matter for just 100. It's fine. Okay, let's see if we have improved the score. Okay, so we can see that we improved a little bit here by making the model go and fully train until there is nothing to learn from the data. So now I'm going to show you the effect of the subsample. So let's uncomment this, keep this one here, and copy paste, and see what this one does as an effect. So one thing that we can notice here is that the first one is better here. So you can see that we went from 96 here to 94, which is kind of nice. Here as well, you can see an improvement. So you can see that giving the model different parts of the data set each time it grows a tree gives them the ability to generalize better on an unseen data, and this is what we want to achieve in any real world scenario. So the same thing was achieved in the third one. This indicates that the model is really performing well when you give it different samples each time. So here, decent improvement. You can see that we went from 98 to 96, which is very encouraging. Now let's see if the other parameter is better, makes it better. Okay, let's copy this again and see what it does. So as a reminder, this parameter enables every time you grow a tree, you take only 90% of your parameters or attributes or features. So here we have something like 50. Normally it will take something like 49 every time. So in the same way we're learning from different parts of the data, we're forcing the algorithm to learn from different attributes, which is kind of good as well for the generalization of the model. So same thing here, we can see some improvements here, and then we went down here as well. This one also not a huge improvement, but it's an improvement anyway. So it's a good thing. We're doing the right improvements here. So let's see now if we decrease again this one, does it make the model better or worse? So we've seen that making it less improves the results. So what I do now is go again and then try with less depth, or make the model less complex. So when the model is less complex, you're closing the gap between these two. You're making the models much simpler, so that, and by experience, it makes these two values closer together, which avoids overfitting. So let's see, and you can see now that those two are closer. So we went from 0.2 to 0.4, and then also this one we went from 9.3 to 9.4. Okay, so the model doesn't need high depth in the tree. So this is an indication for you. It doesn't learn much complex rules, and you can see that it avoids also overfitting, and it's improving everywhere. You can see here it's improving, and here the same for the third, I guess. It's going to improve. Yes, we can see that it's going down. So yeah, good thing. Probably want to keep that way. I'll decrease it again and see what is the effect of that on the model. Okay, so if we look at the results, the results went down again, which is encouraging that we are going into the right direction. So let's go back again, make this as 3, and do it again until this is no longer improving, and then we can move to the next one. So let me go into this page and also show you some parameters that I also use to avoid overfitting. This one and this one. So these two are very good if you want to make your model less prone to overfitting. So minimum child weight is the number of instances you have in a leaf. So you want to, I start with something like 5, then 10, then 15, then 20, until there is the gap between the train and the validation is less than 10%. And the max delta step, this limits the steps that you take every time the model is learning. This is good if you have imbalanced data by experience when your data is extremely imbalanced, and I will cover this in another video. There is two parameters that you want to use together. So the scale positive weight, this gives a high weight to the minority class, and they give you here the formula to use. But again, don't use what they give you straight away. You want to improve that, and by experience, when there is very high imbalance between the classes, I usually square root this to limit, if there is 1 out of 1 million, then this value becomes too high, and the learning steps becomes too high, and this is why I make square root to limit this value. And also I use it along with max delta step, which helps the algorithm not to take too big steps when it learns from a sample. You want to limit that. No matter what example you have, limit the delta step so that you don't go too far in your changing your parameters, and then you can improve it the next round. So if we go back, we can see that again with a much simpler model we are improving. And then the model now didn't finish training, so we have to increase the learning rate. So you get the idea on how you should play with those to make it better. So this is for when you start. I start with this configuration. I usually try to improve every time until I get a valid parameter. And one thing that people have been asking me recently, especially when they do Kaggle, there is a difference between doing a Kaggle. If you look at the leaderboard, and you can see that there is 100 people having like this score right here. So between the number 50 and the first one is like 0001. But in real world scenarios, if you are in a project and you want to build a model, you don't really care about having a difference between 0001 and this one. And another thing to keep in mind is that maybe the first one here have built a good model, better model than all the others, but it's so complex. It's maybe an ensemble of 3 or 4 different kind of algorithms that gives him this result. And in real world projects, you want to avoid having high complexity, because between this one and this one here, the difference is so small, and this one can be achieved with a much simpler model. So keep in mind that when you do your projects, you don't want to build a too complex model. I'm saying this because what I'm showing you here, these hyperparameters, if you tune them the way I showed you, you will be able to achieve decent and good performances very quickly. And then after that, you can do some feature engineering to improve it, but you don't really need to be on the top of the table and do some complex things. You want to keep your model accurate and working, and to do that, you can simply use the technique I showed you in this video. So this is pretty much everything I wanted to cover in this section. I'll put other videos next to handle the cases where we have high imbalanced data and how to treat that with Xgboost. So please subscribe to my channel, and if you have any questions, put them on the comment. I read them a lot and I'll be able to answer them. Thank you.